Hi everyone, this is Dr. J. Ravindranath Reddy, working as Assistant Professor of Mathematics in MLR Institute of Technology, Hyderabad. So in this video, we are going to discuss the course of numerical methods and integral transforms. In this course, we are going to discuss the first concept, that is interpolation. In this interpolation, we are discussing central differences here. So first we will see what is a central difference and how to construct these central differences and Gauss forward interpolation and Gauss backward interpolations. So first we will take this. So already in the previous videos we have seen Newton's forward interpolation. So that's Newton's forward interpolation is used to find out the value of y at a given particular value of x whenever that x value lies at the beginning of the table here. So whenever the x lies at the beginning of the table, then if you want to find out the value of y from the given data, then we can go to the concept of Newton's forward interpolation. And similarly, this Newton's backward interpolation is used to find the value of y at a particular value of x whenever that x lies at the ending of the table. So whenever the given x value lies at the ending of the table, then if you want to find out the value of y, then we can go to the Newton's backward interpolation formula. So now whenever that x lies at the beginning and at the ending, then we have seen Newton's forward interpolation and Newton's backward interpolation here. Now whenever that x value lies in the middle of the table here. So whenever the x lies in the middle of the table, then we have to go to the concept of central differences here. So now we will derive the interpolation formulas to find the value of y at x value whenever that x lies at the middle of the table. So this is the point we are going to discuss in this video here. So now in order to find out this one, we have to construct a central difference table. So in order to construct this central difference table, in the previous Newton's forward and Newton's backward, whatever the value lies at the initial stage, we have considered that x value as x naught value. And whereas in the Newton's backward interpolation, we have considered that x value as in ending of the value as xn value in the Newton's backward interpolation. So now, whenever we want to apply this central difference table, we should not consider the initial value as x naught and the last value as xn. So we have to consider the x naught value that must be in the middle of the table here. So let us construct the table here. So imagine that this is the x value. So I consider this x value, that is which is nearest to this value x naught. And whatever the values we are having above this x naught, we have to represent with the negative side, that is x suffix minus 1, x suffix minus 2. And suppose if you want, you can go for if you have another number, we can represent that x suffix minus 3. So like this we can give the values above this x naught, and whenever the values of x we are having after x naught, we have to represent with x1, x2, and if you have any other values, we can represent with x3. Now we have to represent these corresponding y values as we discussed in these previous videos. So whenever we have considered that x value as x naught, its corresponding y value is represented with y naught. So when x is equal to x1, its corresponding y value is y1, and similarly when x is equal to x2, we can consider this corresponding y value as y2. And as usual, you take the differences of these two. So that is y1 minus y suffix minus 1 minus y suffix minus 2. So if you find out the difference, that is represented with forward operator, that is delta y suffix minus 2. And similarly, take the difference between y naught and y suffix minus 1, that is represented with delta y suffix minus 1. And like this, we have to find out the differences of all the y values. We will get our first differences of y. So we can also construct this central difference table by using the help of this forward difference table, which is forward difference operator delta. And take the next one. In the present column, take the difference of these two numbers, which is represented with delta square y suffix minus 2, and now take the difference of these two numbers, which is represented with delta square y suffix minus 1, and the difference of these two, which is represented with delta square y naught. So like this, we have to continue this table until we get a single value in that particular column. So this is our central difference table. I'll explain this table by taking one example here. So let us take the one example for the how to construct the central difference table here. So now this is our problem. So now we have to construct the central difference table for x is equal to 38. This is the data he has given. Now for this data, we have to construct the central difference table for x is equal to 38. Now whatever the data he has given, you take that x values and y values here. So these are the x values and these are the y values given. So whereas in the Newton's forward or Newton's backward, we have represented these x values as x0, x1, x2, x3, x4 like that. But here, we should not represent these values here. So like say like forward and Newton's forward and Newton's backward, we should not represent these values of x as x0, x1, x3 and so on. So now first what we have to do is, our task is we have to identify the value of x0 from the table. So in order to identify that x0 value, we have to concentrate on this x is equal to 38. And x is equal to 38, we have to identify the nearest value for 38 in the table of x values. So here the nearest value for 38 is 40. So this 40 we have to represent with x0. So now represent this value as x0. And whatever the values we are having less than this 40, we have to represent with a negative sign, that is x suffix minus 1 and x suffix minus 2. And above 40, we have to represent with x1 and x2. And now represent its corresponding y values as y suffix minus 2, y suffix minus 1 and y0 and y1 and y2 here. So like this is a very important thing here while you are constructing this central difference table. So as usual, now find out the difference between these values. So 14.9 minus 15.9, you will get this value as minus 1, which is represented with delta y suffix minus 2. Now take the difference of this. So 14.1 minus 14.9. So this is minus 0.8. This is represented with delta y suffix minus 1. Now take the difference of this. So 13.3 minus 14.1. So this is also minus 0.8. So this is represented with delta y naught. And next, find out these last two differences. So 12.5 minus 13.3. So you will get this is also minus 0.8, which is represented with delta y1. So this is our first differences of y. And similarly, take these two differences here. So minus 0.8 minus of minus plus 1. So you will get this is 0.2. So this is delta square y suffix minus 2. Now take this minus 0.5 minus of minus 0.5. It becomes plus, so you will get 0. And this is also equal to 0. So this is represented with delta square y suffix minus 1. And this is delta square y suffix y naught, y suffix 0. Now find out these differences once again. So 0 minus 0.5, that is minus 0.2. And this is 0. 0 minus 0 is 0. Now find out the difference this, you will get 0.2, which is represented with delta square delta power 4 y suffix minus 2. This is delta cube y suffix minus 2. This is delta cube y suffix minus 1. So this is the way how we can construct this central difference table. The important thing is everything is similar to the previous. The important thing is identifying the x0 value in the given data. So once if you identify this correctly, then we can construct our central difference table here. So in the central difference concept, we are having two interpolation formulas. One is Gauss forward interpolation and the next one is Gauss backward interpolation. Now this is the standard formula used to apply Gauss forward interpolation here. And the Gauss backward interpolation, this is Gauss backward interpolation formula. And this is the formula to find out the values for both Gauss forward and Gauss backward interpolation, that P is equal to x minus x0 by h. Okay, in the next video, we'll discuss when we have to apply this Gauss forward interpolation and Gauss backward interpolation. So now in this video, we have discussed how to construct the central difference table and what are the formulas we are having in the central differences here. So in the next video, we can go for the Gauss forward and Gauss backward interpolation formulas. When we have to apply this Gauss forward, when we have to apply this Gauss backward interpolation formula. Thank you.